Today's target will be multiplying polynomials. By the end of today's lesson, you'll be able to multiply a polynomial by a monomial. You'll be able to multiply a polynomial by a binomial. Remember that a monomial is a single term, a binomial is two monomials being added together. And what we will be using to multiply polynomials will be what we call the area model. So we're going to start by showing you how to use the area model for just multiplying two numbers. So if we were doing 6 times 4, we would say we have 6 on one side, 4 on the other. So that means we have 4 rows, and we have 6 columns. So 4 rows, 6 columns, and if we were to count up all of the boxes inside, so on and so forth, we get to 24 total boxes. So that tells us that 6 times 4 is equal to 24. So we're going to use that same logic, same model, to multiply polynomials. So here we have a monomial in 2x times a binomial in 3x plus 1. We're going to draw out our area model. We have a 2x, and then we have a 3x, and a plus 1. Whenever you have a binomial, you have to split up the box. So since down the side we only have 2x, we don't need to split that up, but across the top we have a binomial, so we draw a line between the 3x and the 1. So in our first box, we're going to do 2x times 3x. 2 times 3 gives us 6. X times x, remember from our exponent rules, would give us x squared. And then in our second box, we would do 2x times 1. 2x times 1 is simply 2x. And then our answer comes from what's inside the boxes. So in this case, 2x times 3x plus 1 is equal to 6x squared plus 2x. So just to recap real quick, you have your two factors, the monomial factor and the binomial factor. Those would go outside the boxes, and then you draw a line to separate up the binomial, and then you multiply together to fill in what goes inside the boxes. Here we have an example where we have a binomial times a binomial. So we're going to draw our box. Let's make this one a little bit bigger because we're going to have a binomial down the side, 5x minus 2, and then x plus 7 across the top. I got a little bit ahead of myself, and I drew the lines ahead of time. But basically what we've got is that we've got a line to separate up the 5x and the negative 2, and a line to separate the x and the positive 7. So in this first box, we're going to do 5x times x, which gives us 5x squared. And then 5x times 7, which gives us 35x. In the second row, we're going to do negative 2 times x, which gives us negative 2x. And then negative 2 times positive 7, which gives us a negative 14. Once again, the answer is what's inside the box. So we have 4 terms. And you're going to notice when you do it like this, these two terms are always like terms. So when we write our answer, we've got 5x squared. We've got a 35x. We've got a negative 2x, and we have a negative 14. These two terms in the middle, like I said, are like terms. So I'm going to add them together. 35 minus 2 gives me 33x. Then I bring down the minus 14 and the 5x squared. And there's my final answer. So there's a binomial times a binomial. All right. Last example is a binomial times a trinomial. Draw our boxes. We've got a 2x and a positive 1 down the side. I'm going to go ahead and draw a line to separate those two. And across the top, we've got x squared, 5x, and then negative 3. And I'm going to draw lines to separate those guys as well. And now I'm going to do my multiplication. 2x and x squared gives me 2x to the third power. 2x and 5x gives me 10x squared. 2x and negative 3 gives me negative 6x. Dropping down to the second row, 1 times x squared is simply x squared. 1 times 5x is simply 5x. And 1 times negative 3 is simply negative 3. So just like the previous two examples, what we have inside is our answer. So once again, we have 6 terms here. And similar to what we just did with the binomial, notice that along these diagonals, we have like terms. So our first diagonal, x squared and 10x, adds together to give 10x squared and 1x squared adds together to give us 11x squared. And then our second diagonal, 5x and negative 6x combine to give us negative x. So when we write our answer, we have the 2x to the third power. We combined our x squareds to get positive 11x squared. We combined our x's to get negative 1x. And then we have that negative 3 at the very end. So there's our final answer. Okay. Key thing to remember is that when you multiply, you have 2 factors that you're multiplying together. Factors go outside the box, outside the area model, and then the answer is what we find out inside. So now it's your turn. You've got 2 problems. You got a monomial times a binomial and a binomial times a binomial. Go ahead, press pause and try them both now. Here we go. Number 1, we have the 5x down the side, the 2x minus 4 across the top. Drew the line to separate the 2x and the negative 4. Multiplying gives us a 10x squared in the first area and a negative 20x in the second. So our final answer would be 10x squared minus 20x. Number 2 is a little bit more difficult in that we have 2 binomials. So when we draw our area model, we have to draw a line to separate the 3x minus 4 down the side, and a second line to separate the 7x plus 3 across the top. 3x and 7x gives us a 21x squared in the first box. 3x and 3 gives us a 9x in the second. Dropping down to the second row, negative 4 and 7x gives us a negative 28x, and negative 4 and 3 gives us negative 12. We look across the diagonal and find our like terms, our 9x and our negative 28x. Adding them together gives us a negative 19x. So we write our final answer. We have the 21x squared, we have the negative 19x, and we have the negative 12. Keep in mind that when I'm writing my answers, I always do it in order of the greatest exponent to the least. So we've got the x squared, the simple x, and then the term without an x, or the constant. So please get in the habit of doing that as well. As always, if you have any questions or concerns or need any further clarification, please make a note of that so you can get that cleared up when you come into class.